This lesson is going to cover some material out of Units 7 and 8. We're going to look at, this is Box A, we're going to take a look at the Pythagorean Theorem, which should be a little bit of a review from grade 8 for you. So by the end of this lesson, what you should be able to do is to be able to explain how the side lengths of a right-angled triangle are related to one another and solve problems using the Pythagorean Theorem. And the first point to make about the Pythagorean Theorem is that it applies for right-angled triangles only. So you've got to see this right angle, or this little square here, inside the corner of your triangle in order to be able to use the Pythagorean Theorem. If it's not a right-angled triangle, you're going to learn next year how you handle those types of triangles. But for now, make sure that you've got a right-angled triangle that you're dealing with. Now, when you see a right-angled triangle, the first thing you want to do is you want to find the side that is opposite to that right angle. It's always going to be the longest side in the triangle. Do you remember from last year what we call this longest side, or this side that's across from the right angle? It is called the hypotenuse. So you want to find that first. Hypotenuse. And I'm going to label it hypotenuse. You're not going to label it the hypotenuse. Okay? But once you've found the longest side, it's helpful to label it with a letter. And we usually use C for the longest side. And then the other two sides, or the shorter two sides, we usually label them A and B. How are the lengths of these three sides related? Well, they're related by what is called the Pythagorean theorem. For a right-angled triangle, the square of the length of side C, or C squared, is equal to A squared plus B squared, or the lengths of the other two sides squared and then added together. Or, if I take the square root of both sides of these, I can write that C equals the square root of A squared plus B squared. And this is the Pythagorean theorem in these two forms. Okay. Of the two forms, I think this one right here is going to be the one that is most useful to you. Okay. So in that little space on your page there, just jot down those two equations. Okay. So you've seen this, I think you've seen the Pythagorean theorem before, so we'll jump into some examples right here. Okay. So here we've got triangle labeled ABC. We're told the length of this side here and this side here. And in each of these, what we want to do is we want to find the length of the unknown side. Let's try that again. Unknown side. And by unknown, we just mean that we don't know the length of it. So what I always do is, first thing I do, I find my right angle. I go across the triangle to my right angle. That way I know which side is my hypotenuse. In this case, I'm going to label this hypotenuse with C. Okay. From here, I'm going to use my Pythagorean theorem. I know that the Pythagorean theorem is C squared equals A squared plus B squared. I've already labeled one side C, so my other two sides, my two shorter sides, I can label them A and B. And then I'm going to sub in the lengths of A and B into this formula here. So I'm trying to find C, so I'm just going to leave that as C squared. Length of A is 5, so that becomes 5 squared. Length of B is 12, so this becomes 12 squared. So I'm just subbing those numbers into that formula. And then from here, we evaluate using order of operations. We would do brackets first. We don't have any brackets, so we can't do the brackets. Then we evaluate our exponents. So we've got 5 squared and 12 squared. So 5 squared is 25. 12 squared is 144. Okay, so C squared is 25 plus 144. We don't have any multiplication or division, so next we've got addition. So we want to add 25 and 144. So C squared is going to be 169. And then we finish off by taking the square root of both sides. It's like we see c squared on one side. We want to just have c equals, so we're going to do opposite operations. And the opposite of squaring something is taking the square root. So c is going to be the square root of 169, or 13. And let's see, we check, were we given any units in this question? Nope, so our answer is just 13. Okay. All right. Let's try the next one here. Okay, we've got, again, a right angle triangle. We know it's a right angle triangle because one side is labeled with this little square here. We've got one side is 20, one side is 25, and one side is labeled x. First thing we want to do is we want to find our hypotenuse. Which of these three sides is our hypotenuse? Andrew, the 25. How did you know that? It's directly across, yeah. So I'm going to label that C, and the other two, I'm going to label them A and B. And once again, we're going to use C squared equals, whoops, not plus, C squared equals A squared plus B squared. Okay. And then let's substitute in. C is 25. So on the left side here of this equation, we are going to have 25 squared. A is 20, so we're going to have 20 squared. And B, well, B and X are just two labels for the same side. So instead of B squared, I'm just going to have X squared. Okay. Now this one is a little different from the last one because notice, what we have is we have a number over here equals a number plus this unknown. Okay? Whereas in our first example, we had our unknown C on the left-hand side all by itself. So how can we do this? Well, let's start by doing our order of operations. We've got 25 squared and 20 squared. Let's square both of those things. So let's see, what's 25 squared? I got to punch this into my calculator. I get 625. What's 20 squared? Oh, I got to punch this into my calculator too. 400 plus x squared. Now, what we have here, it's like an equation, like those equations that we were solving back in Unit 5-6. We want to get that x, that variable, all by itself on one side of this equation. So what are we going to do? Well, we see 400 added onto this x here, so we are going to subtract 400 from both sides to get the x squared all by itself. So I'm going to subtract 400 here and subtract 400 over here. When I do that, I end up with x squared on the right-hand side and 225 on the right-hand side. So 225 is x squared. How do I find out what x is? What's the last step here? Stephanie? I'm going to take the square root. So I'll just bring this over here. X is going to equal the square root of 225. So x is going to equal 15. Okay. So sometimes we end up with a little equation that we have to solve. The last one is the trickiest kind that you're going to see. Okay. I'm given a right angled triangle here. I've got a 12, and all I've got here are these two tick marks on these two sides. When you see those tick marks, what does that tell you about the lengths of those sides? They are the same. So this side and this side are the same length. And we don't know what the length of those is. Okay? So we're just going to choose a variable to represent it. I'm going to choose this side to be, I'm going to call this x. And because this one and this one are the same length, I'm going to call that one x too. All right. Now, right angle triangle. So first thing we do, we see that it's a right angle. We find our hypotenuse, which is across like this. I'm going to label that C. I'm going to label this A. I'm going to label this B. Pythagorean theorem, c squared equals a squared plus b squared. Let's sub in what we have. We know that c is 12, so we get 12 squared equals, a is x here, x squared, and b is another x squared. So I've got 12 squared equals x squared plus x squared. Again, this is another equation that we have to solve. Left-hand side, 12 squared. We can do that squaring and get 144. What can we do with x squared and x squared on the right-hand side? They are like terms, so we can add them together. If we've got 1x squared and 1x squared, 2x squareds. Okay. Now, we can solve this thing for x. We see 2x squared, so we see a 2 that is multiplied by x squared, and then we see an exponent there. So remember, when we're solving equations, we use the opposite of our order of operations. We do subtraction or addition first. We don't see any of that. We see multiplication times 2, so we want to divide everything by 2. So what we're going to get is x squared on the left-hand side, on the right-hand side, sorry. On the left-hand side, 144 divided by 2. We punch this into our calculator. We get 72 equals x squared. And then what's the last step here? We want to take the square root. So x is going to equal the root of 72. And we end up with, using our calculator, 8.49. And I'm just going to leave 2 decimal places. 2 decimal places are always good. And that's the Pythagorean theorem.